everybody, my name is Zach, and today we're learning about vacuum thermoforming. So this is our vacuum thermoforming machine, and the first thing you're going to notice is this thing is super old. It was actually manufactured in 1967, so if you go to an industry, you're never going to see a machine like this. However, the process is still the same, and this machine will give us a good window into what's going on.
But now before we get started, I think it'll be really important to talk about the material we're using today. It's called PLA, aka polylactic acid.
Now guys, this stuff is this material from the future. So it's a thermoplastic that's completely made from corn byproducts, and it's 100% biodegradable. However, this means that it can't be melted. So with a normal thermoplastic, we melt it down as a liquid, and we can put it in any shape we want, and then we can reharden it back into a plastic. However, you try to melt PLA, it'll start to break down and begin that biodegrading process. So this limits the number of manufacturing processes we can actually use with it. For more information on PLA, I highly recommend you check out the graphic in your lab manual.
So this right here is the mold to our vacuum thermoformer. Now if you look real close, you're going to see a bunch of tiny holes in the bottom of it. That's because our plan is we're going to be taking a sheet of plastic, putting it right on top of this mold, heating it up to the point where it's not a liquid, but it's still very, very soft, and then sucking a vacuum down through this hole, drawing the material into the mold, and it will take this exact shape.
So first we load the machine with our sheet of PLA with dimensions you can see on screen. Then we got our vacuum ready by drawing a vacuum down to 25 inches of mercury. Next we spent 37 seconds heating up that PLA to 251 degrees. You can see it's so hot it can barely support itself. It's that bubble hanging down below. And then finally magic happens and we drew the vacuum and our part was completed. We left the vacuum on for 10 seconds and within another 10 seconds it was already cooled down, ready to handle. Here's an example of some products that were vacuum thermoformed. Notice that they're all larger at the top than they are at the bottom. This is called a draft angle. They need this draft angle built in to be able to release them from the mold. If it were 90 degrees or somehow large at the bottom, they'd be stuck in there forever and we wouldn't be able to release them. This is kind of a limitation of vacuum thermoforming as there's only so many different shapes that we could make. Finally, the last thing we need to talk about is draw ratio. Draw ratio is kind of a measure of how much we stretch the plastic during its vacuum thermoforming. Let's take a look at the cup on the left. If we divide its height by its width, we get its draw ratio. So the cup has a draw ratio of 1.315, while our shallow tray has a draw ratio of 0.218. And you can see how these draw ratios definitely correlate to the shape of the part once it's done. That's all I have for you guys today. Thank you for watching, and I'll catch you in the next lab.